So the first question which was pending was like, no, a discussion like, okay, if we want to have a logically centralized control, but we have multiple providers, which we have multiple dominant providers, how can that ever be realized in practice? Or is that, what are the ways to achieving that? And I assume it arose in reference to the talks that were given by, I believe, Jennifer, and I think also probably David and Scott. I mean, I may be mixing up the panelists, so I apologize for that. But would you guys like to comment on that?
Yeah, I can give a quick answer. I think the simplest case is that you could imagine logically centralized control taking place within a single administrative domain. So within Amazon, within Facebook, within Google, rather than across them. I think a second step is you could imagine logically centralized control at the juncture points between them, you know, exchange points or the nodes that Scott talked about in his presentation. A third is that you could imagine protocols between the controllers of different networks. And a fourth option is that I alluded to one of the other questions earlier, is you could imagine that the whole network is virtualized so that, you know, let's say Google is connected to Comcast, you know, that could be two controllers, one in Google's network, one in Comcast's, or Comcast could have a virtualized infrastructure that Google can control a slice of, in which case there could be one controller end to end over resources partially owned by Google and partially owned by Comcast. I think all of these are still to play out. I don't know exactly which one's going to actually take place, because for the most part, this really takes place right now within a single administrative entity.
Thank you. Anyone else would like to comment on this?
So Jen, maybe I would just follow up and ask you, do you think there's a need for that kind of multi-hop end-to-end control? I mean, is that something that's so needed that people are going to really be working on that hard? Or, I mean, the models you just talked about make a lot of sense, but is it super crucial?
I don't know that it is. I think it depends a little, like in David's talk, that if we end up getting, you know, one provider all the way up to the last millisecond, that may not actually be important. I think the thing that we probably don't need is more than two hops. You know, there's the sending network and the receiving network at most, and maybe not even that in some cases if the content's actually co-located with the access network. So I think the convergence of the edge with the cloud is making that less and less important.
Yeah, actually, I would be interested in hearing Jeff's opinion, because when Jeff concluded with the need for referential, only the self-referential versus services, in some sense sounded like a direct contradiction that, hey, we do not need this type of logical centralized control. So I would just be interested in hearing him, whether he agrees or whether he has any opinion on logical centralized control being needed in a collection of services.
I don't think it's needed as a central tenet of where we're heading. We're heading not only into a world of abundance, but a world of pre-provisioning. And you see it in so many places now that I download a web page and my device actually looks at all the URLs on that page and downloads them for me as well. So my device is now anticipating every possible move I could make. And all of a sudden it's my device that is orchestrating these services, neither the network or the remote edge. And I don't need to wait for anything. And you see it right now in the latest versions of Apple's iOS with this pre-provisioning model. And that's not even 50 years away. That's what we're doing today. So once you manage to get an extraordinary level of abundance of computing, storage and communication right at the edge of the network, right in the device itself, all of the work that we were doing to try and shave stuff out from the middle is replaced by massive amounts of abundance. And I don't even need to be that accurate about my anticipation. I just need to bring everything down. And at some point, it just doesn't matter what's right and what's wrong. If the stuff is all there, then instantly this stuff is blindingly fast. There's a huge amount of it. And as a consumer, all my dreams have been answered. And so I suspect that the real competition to the CDN orchestration we're seeing in the world of trying to crowd out the customer by basically marginalizing the network and leaving only the access network left is then going to be a fight between the access network and its capacity and the intelligence of the device itself. And the folk who realistically have control of both the device and the content inside this world are currently Google and Apple. And if you think about the internal conversations between, do we build a bigger, better CDN, or do we just pump more stuff into the storage on our Android devices or on our iOS devices? Gee, that's an interesting conversation. Because at some point, the edge always wins. Because until Moore's law just dies flat on its back howling at the moon, until that point, we can keep loading more. And we can keep putting more and more. We can talk about terabytes in a device as big as my watch. And if we're talking about that, then the ability to anticipate gets rid of all the arguments around control structures in back-end networks to try and fake the fact it's not there already. So that's, I think, the competitive tension over the next 50 years. Bigger, better control models for bigger, better CDNs versus just anticipate anything that could possibly happen and download it in advance. Interesting tension.
So I agree with Jeff on some of that. I think where we hit some limitations, one is just how much energy you can pack into your watch, because I think that's ultimately going to be that limitation. How much, and if it's a, even smaller smart dust type sensor, how much energy you can pack in. So that's going to encourage you to think about how you want to share, perhaps, between the edge and somewhere close. I think the other factor, though, is when you actually want to fuse information from multiple parts of the edge, multiple edges, and multiple devices. And I think there's going to be some, desire to fuse information close by. So that's on kind of your comments, Jeff, but I want to sort of back up just to, kind of the question around what I think of as, SDN exchanges or SDXs. And, there I think, well, I kind of agree with Jen that, all you really need are these point-to-point bilateral arrangements. You definitely, I think, are going to want to see that between the access network and, say, the hyperscalers network. If we could get SDXs, and we probably have a very small window to try to get them before the bilateral arrangements kick in, they would give us visibility, right? If not, visibility into what is going on in the network is going to be kind of almost, I don't want to quite say forever, but lost for a long time to come. So I sort of say that, the research community should be trying to get those SDXs established as quickly as we can. Sorry, I actually did mean to, I forgot one comment, Jeff, is absolutely agree with your comment around, sort of Apple and Google are in very interesting positions, being involved in both sides of this. That was part of why I was kind of really enthusiastic about them being involved in this NSF Rings program and kind of bringing them together, with the people that work on the access networks.
Yeah, I want to add a comment about the energy issue, which I pointed out actually when I started my talk. But there are a lot of progresses how to provision devices, because for bio and nano things, the energy supply will be critical. And there is even an announcement on the ACM news about some new approach. So there are ways to provide energy to those devices. I must say that I agree a lot with Jeff also about the point that the edge will be the key. Some form of, however, centralized or semi-decentralized control will be critical for security and resiliency. Because sometimes when you have a large scale attacks, you can only observe if you collect data from multiple points in the network. But locally, you may not really understand what's going on.
I'll maybe just add two somewhat related points to this whole kind of both for centralization and maybe SDN part, and maybe indirectly to the edge part, is that increasingly your ability to not be affected by things that happen elsewhere will matter, so that too tight a coupling is probably not what most entities will want, simply because you don't want to be brought down because some other network is having problems, or that or that you indirectly, and this is why I worry about things like slicing, that you're giving other entities inordinate control over network resources in quote your network, which then if things go wrong, either accidentally or intentionally, somebody finds a flaw in your security and admission control system, then you're exposed to a fair amount of risk. So I would argue that isolation capability, not just a traffic isolation, but simply that having very limited control interfaces is actually a benefit to I think indirectly what Jim was saying. The other piece that I think we tend to ignore it, to our predictive failure is that whatever systems we have, somebody has to pay for them. And if we don't just want to have kind of a model that Jeff was talking about, that everything is paid for by our privacy and data, we really have only developed roughly two models besides the advertising model, namely kind of consumers pay for access via some typically very small number of providers, and for practical and just keeping track of it reasons, and psychological reasons, quite honestly. People just don't want to keep paying for stuff, and the content of in some cases, or maybe services of some sort, like email services that companies pay for and so on. And it's been really hard to get people to pay for intermediary type services in general. And so unless there's a model, this goes a little bit to kind of a layer 3.5 type of one, that where there is a clear payer that has aligned interests and doesn't just want to do that themselves, it's been hard to get these services up and running. I mean, again, the CDN model, the brilliance compared to multicast was not that it was more efficient. It was that somebody was actually willing to pay commercial providers of that service who were never willing to just pay the carriers for multicast services at a scale where that was deployable. And so I think we should think about what the business model is, who's paying whom, in addition to what we would like to deploy technically.
Thank you, Henry. That's a very good point. Any other comments, any other opinions from any other panelists?
So
want to say
I
one-
wanted to end on a note, if I could. It's interesting that for a panel that's dedicated to discussing the internet, we take the presence of hyperscalers as a permanent fact of life. The hyperscalers are much younger than the internet, and there are reasons to think that they will not last forever. Cloud computing, I think, is one of the few sort of global services that never learned to federate and has sort of been built on a very proprietary model. It's not clear that that's going to be sustainable. I mean, certainly, you know, our work here at Berkeley is sort of arguing that it's not, that there will be a sort of a more compatibility based. If you look at the clouds now, they're growing towards compatibility, not because they want to, but that's where their customers are. So I think that the world may once again go through a decentralization revolution that I think will greatly change the flow of money, which will, you know, as Henning's comment, greatly influence the shape of infrastructure. So I'm not saying I understand how it will evolve, but we shouldn't take the hyperscalers as a given axiom and then design our internet as if they are a permanent fact of life. That's the only note of caution I would add.
May I ask a question in response to that? Are you alluding to the so-called Web 3.0 mechanisms?
Not at all.
Good. I'm very happy to hear that. Okay, thank you.
But are you alluding to the so-called sky computing?
Yes.
Just to put you a softball.
I mean, it is sky computing, but that's a particular proposal, but it's this recognition that multi-cloud is coming, that if you look at the forces towards compatibility among the clouds, It is being driven by the customers. It's being driven by, forces like Snowflake, which is housing their service on multiple clouds. So it is now much more possible to have workloads running on several clouds. Once that happens, the margins are going to start being driven down, and it's going to start looking more like an open market. And I think that's going to have a very important effect because these hyperscalers are built around effectively monopolies. That they sort of have these services that can afford to build out these huge infrastructures, and that may change.
If I can pile onto that, I am in violent agreement with you. Is you look at the forces that are growing Kubernetes, we see it becoming a leveling thing across all sorts of mechanisms. I've got a little cluster of Jetson Nanos behind me running Kubernetes of all things. And the remarkable thing is I can now fairly easily move containers from my local cloud to another cloud to an edge. It's really remarkable how it federates all of those various clouds.
Yeah, complete agreement. Yeah.
And I think in the spirit of some of Scott's earlier comments, this is perhaps something that we shouldn't just, predict. It's something we should work towards and try to make happen. I did want to also perhaps, well, you know what, I'm going to pause there and let us go back to other questions. Sorry.
I think that still gets back to my point about the key technology being one around referential capability. Because when I can take my Kubernetes boxes and literally just push them out somewhere, at some point when they need to deliver some coherent thing, service, whatever, knowing where it might be to do that is actually useful, because otherwise there's no point sending it out into the world. And so every single time we devise a new technology, we create effective monopolies by the early entrepreneurs that lock it. And then we start moving around it, commoditizing that and orchestrating a level above. We actually create a different kind of centrality problem. And I think in terms of getting rid of the central role of these CDN aggregating folk and moving an upper level into these federations of cloud computing, you're actually stressing and emphasizing. The point is really about where are things? How can I pass to you that reference?
Yeah.
And the lingua franca of that network moves, I suspect, from the DNS outward. And it doesn't move from addressing or protocol or anything else. And knowing how to find things, in other words, in simple terms, where things are, becomes the critical attribute of that level of networking. Now, we're probably going to move beyond that, but I have no idea. At that point, my brain explodes and, I'm done. But it seems that we're talking about this problem of once you defederate, and once you move it around, which is where we want to go as consumers and so on, then where are they becomes the critical point of orchestration.
X500 on blockchain, that's what we need.
Oh, thank you. Someone had to say it.
Yes.
So Jeff,
quantum blockchain.
Jeff, you're just talking though about building another layer of abstraction and a new service on top of existing services. So I guess what I would, and I get what you were saying about the importance of referentiality or reference or whatever the word is. Do you think that there's anything that needs to be done under the covers to do that? Or is that just sort of the next application area where there'll be a lot of emphasis?
I think it gets back to this fundamental issue that the internet is largely driven by, investment cycles. And at this point, if I want to compete with the incumbents, I need to wander up and down Page Mill Road and ask for 9 or even 10-figure sums to make a difference. And that's close to impossible to deliver a compelling story. I need to get around it. I need to actually leverage the existing investment and make a difference. And that's why these layers of indirection happen, because it's cheaper to actually successfully innovate by leveraging existing investment, but not competing head on. And you see it in almost every kind of market. I'm going to specialize in the DNS. So am I, so am I. And the customer says, well, all three of you are really good. How can I buy one service that uses all of the resiliency and capacity of the other three. And so this is why I think it is, layering itself up one on one at one level of indirection every single time we do a generation of change, because economically that's what makes sense.
Well, I only partly agree there, and I'll say a few things. One is that we don't layer forever. What actually happens, I think, then is every so often we pancake things down and we say, oh, okay, now we understand the important thing, and we start absorbing it down, lower down, and supporting it. And so I think that there's these cycles of layering on top and then things getting absorbed into the infrastructure. Scott's work on the extensible internet, I think, really could help there because it could help that absorption process.
David, what you're describing is really the whole history of software, which is one of rising levels of abstraction and then refactoring, which collapses those.
And
just seeing it happen again.
And in fact, the history of, computer architecture to some degree, at least, well, actually, I'm not sure if we should call it architecture because it's so Baroque, but it's practiced by Intel. Right? It's kind of keep trying to figure out what's consuming the cycles and then absorb it down into the hardware. I think we can, do similar things in networking. The internet ran as an overlay over, really slow, 56 kilobit phone lines, right? And then,
And I think one could have an argument that actually hasn't happened. I think in 30 years that pancaking and compression down into layers.
I think we're overdue for a round. This is where I'm excited by I think the layer 3.5 work can help unstick this a bit. However, I also subscribe to, I think, Jeff's comments in terms of, and some of yours, what really matters is it's about, sort of those edge devices and people connecting with applications and services. And, we haven't really, I think, quite figured out how to do that well yet. So this is, whether you think of it as the referential work, you think in terms of, getting good at application layer relaying. My own comments were that, part of the content networking was perhaps stuck because it focused a little too much on static content instead of dynamic. I think in terms of service redirection, there's a little bit more to be figured out, I think, before it can be absorbed. So if Scott gets working on EI, so we have the tools in place to absorb it, and the rest of us make some more progress on what needs to be absorbed, I think we can get the timing right.
All I need is Jeff's, 10-figure funding and we're fine.
We know where the money is. We just got to get it out.
That, in my time, and I know that those of you that have submitted grant applications will strongly disagree, I've yet to see a really good idea not get funded. I've seen a lot of so-so ideas not get funded. I've seen a lot of really bad ideas get funded, but I've yet to see a really good idea not get funded. I'm an optimist here.
We do seem to, just to talk on Pancake, I do think actually we're seeing this happening a little bit at the upper layers that primarily with Quick and HTTP3 that become TLS, which used to be kind of 3 layers in a sense and based much separate in that becoming kind of this universal upper layer thing that is separable in principle. And certainly, you can still think of it as 3 layers, but essentially has become one blob, managed largely by one hyperscalers. And that's really become the programming interface that most people who are not writing application directly, kind of one layer below, is experience as that blob. So in that sense, we've had this. Well, this is a good thing, and you can tell that I'm not quite convinced, but that certainly seems to be happening at the upper layers.
Okay, so the chart I took out of my talk at the last minute was about that programming interface. My God, we're still programming to Berkeley sockets, right? We are so stuck in the past, and arguably even it was a wrong turn at the time it was taken, of sort of, networking APIs that are designed to support, telnet, email, and FTP. So
Yeah,
sorry to go on about it, but it's sort of like we really need to get ourselves some good APIs.
yes.
I don't think we do. I don't think the world is platform based anymore. I look at Facebook's app and I see an entirely different future. And I think we're entering the world of the paranoid application. Facebook's biggest issue with privacy is whether Apple and or Google are spying on Facebook. All that information, they've spent all that money about me that they're trying to glean out of my use of their app, they don't want to share with the platform. So the platform software libraries and common ways of accessing the network are rubbish. Google invented Quick in user space because it didn't want to share. And now we're actually seeing the rise of all of this functionality ascending from the platform way up into the app. The app is now a complete operating system. It's sort of everything is a browser, and apps don't run on browsers because you're giving away information to the browser. Trust nobody. And this idea of the valuable application sharing nothing with apart from the mothership of that application, which Facebook, I think, is pioneering, but everyone else is learning so quickly, is part of our evolving understanding about software engineering and stacking. You push it all into user space. You've got enough computing to do that. And so now Quick, a user space transport protocol, is now the world. But nothing else is living anymore because we killed it almost within a year. And everyone has moved over to BBR and Quick for that very reason. The paranoid application wins. APIs, nah, no one uses them. Raw packets spit out of the application. Nothing else matters.
Jeff, whether it's in user space or not, there's still an API that the application programmer is writing to. And my God, byte streams?
But it's an application almost as an internal document. It's not shared with anything or anyone else. Your drivers are sitting in the same application environment. You're not using Apple or Google or Android or anything.
I would disagree and say if you're thinking in terms of how it's shared locally in the moment. I'm thinking about how it's shared amongst developers, how the expertise, how the knowledge of how to use things, how we exchange information at the developer level percolates. And we get some commonality. If you're saying Facebook's developers are going to do things completely differently from anyone else, then nobody's going to be able to develop for the Facebook platform.
I think Google's examples of both BBR and Quick are highly instructive. It was developed in-house and shared with nobody and nothing until it was a mature technology that actually deployed across their quite substantial set of assets, distributed over their data centers, etc. That's the template that in some ways concerns me, that degree of fragmentation of effort and the privatization now of that degree of technology, that this whole issue of what is open, what is an API, what we can teach kids against is becoming less and less a common open standard and more, particularly in Google's case, quite overtly a corporate asset. And I think that should scare all of us. But nevertheless, the imperatives of Google to do that are undeniable. They weren't doing it to be nasty. They were doing it for what they perceived as their legitimate commercial reasons. But everything is hidden. Everything.
So I did want to, on David's comment in terms of socket programming, just my limited view into kind of the current student generation, you could assume that most kind of more systems-oriented students had done, even before they got into networking course, had programmed on the socket model. No longer the case. All they do is, and I'm exaggerating probably slightly, is using Python and other web APIs where their interface, if you want to call it socket, is curl and base Python abstractions for HTTP. So they don't actually see the protocol at all. It is just essentially, they don't even see get and post. They just see some retrieval with a JSON object that they're attached to it, either in JavaScript or in Python as kind of the two languages that most students, so to say, speak these days. nobody learns C anymore. So, unless you had a few hardcore systems people left. So I would actually argue that it's socket API, as sucky as it is, because it exposes a lot of things that we shouldn't be exposing to people, but it's essentially become like programming SS7. In a sense, there's a cast of people still do it, but it has become distinctly a minority among graduating computer science students, let alone graduating students in any other discipline that use computers.
So I don't really disagree, Henning. What I'm sort of arguing for is our networking community, therefore, ought to move its focus way up. There's some, look at what you said, the HTTP sitting on top of that, right? It's just another byte stream interface, right? Eventually, you get up to things that are actually exchanging data structures and application information. Way up, many layers of craft. If we want to learn and find commonality and new wastes, we need to get ourselves and our sites kind of much closer up to where those programmers are.
Yep.
And Jeff, without worrying about whether or not it's, in user space, right?
So at this point, I would like to take a time check. We are about 15 minutes past the hour. And while I hate to be disrupting what's a really, really interesting conversation, I think we need to close. So I want to thank everyone for participating.